Hi everyone, my name is Andrew, and today I'm presenting on Jinta, and you have a part of me right now because I have the hiccups, so I might not talk correctly. So what is Jinta? It's an online engineering analysis and design tool. It's currently focused on only 2D analysis and design. The interface is going to be all HTML and JavaScript, and calculations powered by Python. So progress since my last presentation. I made a lot of UI tweaks. So the drawing interface, you can move it around, expand it, stuff like that. Distributed forces, I did not implement that at all last time, and this time now it works. You could create it, edit it, and delete it. Distributed forces also goes in global X, global Y, global X, local X, and local Y directions. And I made some adjustments to my reaction calculation algorithm, but I did not progress too far on that because I ran into a problem which I'm going to talk about later. And the light side is up now, so you could do simple drawings and see if it calculates anything. It's very buggy right now, the calculation. The progress has been slow but steady, I feel. I ran into a problem with SymPy, particularly with a function called solve linear equations. I've been using this function to solve my reactions. I wrote like half my program based on that function, but it turns out there was a bug. It can only calculate integers, but it gives an error when you're trying to calculate anything that involves floats. So I have to rewrite most of my stuff and use another more simpler function. I've also been optimizing my code a little bit. There was a chunk of code that was comparing if a point was above on the line or below the line, and I didn't think of it before, but I could just use cross product and I could easily get that, and I did not think of that beforehand, so I had this giant chunk of code. So, and I have also been brushing up on my math. That's helping me a lot. So, a demo time. As you can see, this canvas right here, it's dynamically generated. So if you have a smaller screen, say this, yeah, it becomes smaller depending on the screen size and larger. The snapping also works now, so you could say draw a beam member right here, have a fixed end. That's a fixed end support, and add a distributed force right here. Starting point 4 and ending point at 10. So you have a beam like this, and you could also implement this save, so it saves to the database. And if you want to calculate, it saves before you calculate, and this is what it sends to the database. Send to calculate, and this is the answer, which is right now it's unreadable to people, to users, but I can understand it. It's there's no force, no x force on the 0 on support. There's a y force of negative 45 and a y moment of 308.884. I plan on making that more easier to read and with a graph.
Because of the clockwise movement is clockwise,
this is yes, it's clockwise movement because it's a force is going up, so the reaction should be clockwise.
So by looking at the diagram, I can make it come. Okay, no. It's already precise. Can you block that?
And currently it glitches out when I add any joints to it, but I plan on fixing that. And you can add normal Y forces too. Should be able to calculate
It can also have support on both ends, like
yes, it can.
Can you calculate?
A what?
Can you calculate for me?
No. Next week, I plan on doing more calculations and share drawings with everyone that you save it and you share your drawings. So thank you to Sean Sullivan, Professor Murphy, and everyone in RCOS. Any questions?
When you saved it, you didn't put in a file name. Does this mean you can only save one, and when it's saved, is that saved just for you? I mean, it's a website, but
Yeah.
you said it's saved in the database. Is that saved?
When you save it, you actually treat it, and hopefully it's going to be unique. But this describes the drawing, basically.
So how can you open a saved file right now?
No, I'm pretty sure you could display it, but it's yes.
Will you add support for over-determined systems at all?
Yes, I will. Right now, it only solves for determinant.
Right. Hence the linear equation.
Yeah.
Function. Okay.
Thank you.
I actually have one more question. Are you going to add at any point the ability to view what calculations it's running? So, like, let's say I tell it to solve a statically indeterminate.
Yeah. When I first planned this, I really wanted to do that to teach people what the steps were and how you solve it by yourself. I really want to do that.